Part 6. You've seen several different examples, and this is a final example of finding the area of a regular polygon when you're given some of the information. This time we'll be given the radius. This probably takes the most steps because we're not given the apothem. We're going to have to figure that out, that little right triangle. We're not given the length of the side either. We're going to have to figure out that using that little right triangle also. You'll see the steps as we go along. But we'll end up having to set up two trig equations, one for the apothem and one for that little piece of the side. So here's our problem. Find the area of a regular hexagon if the radius is 25. So the first thing you'd have to do if you didn't have a picture is draw a hexagon with 6 sides. And let's see, put in the radius. The radius goes from the center to a vertex, not to the middle of the side like the apothem. So if we draw that in, it looks like that. And like we said just a minute ago, we don't have the apothem, we don't have the length of the side, so we're going to have to go to our little right triangle and do some trig here. So if we draw that in, there's our right angle. And we're going to solve for the apothem and that little piece of the side. So I went ahead and blew up our little right triangle bigger. I usually like to call this side A for apothem. And this side, this piece right here, X. So I'll do the same thing in my big triangle. Here's that X side blown up a little bit. Remember, X is just half of that side. The whole side is 2 times whatever X is. And here's my little A. This we know is 25 centimeters. So what do we need? We need that angle there. So that's what we'll start off with first. Finding the whole central angle and then cutting it in half for this little right triangle. You should know how to do that by now. So we take the 360 degrees and divide it by how many sides there are. 6 of them. We get 60 degrees. Now for the right triangle, we got to cut that in half with the apothem. So this 60 degrees gets cut in half, and we get 30. So in that right triangle, that angle up there is 30. Next, you label your sides. They're always labeled the same. This is the hypotenuse over here, right? Opposite this angle we just found right here is right here, the X side. And the apothem is, I like it, apothem A for adjacent to. My phone's ringing. Let me take a time out. So now that we have the angle, we're going to, step 2, we're going to write and solve a trig equation for this little half of the whole side here, the X side. So you can see we got the opposite side, and we're going to use hypotenuse, and sine uses that. So we're going to take the sine of the angle, 30 degrees, equals the opposite, which is the X side, over the hypotenuse, 25. Then we set it up as proportion, put that over 1. And we're going to go ahead and cross multiply the 1, this bottom times this top. 1 times X is X. The other cross product is 25 times the sine of 30 degrees. So it looks like that now. Now X is already solved for, so we just put this in the calculator. 25 times the sine of 30 is 12.5. So now we know that little piece is 12.5, X is 12.5. So we'll go ahead and figure out the whole side, which is 2 times that, 2 times the X. So the whole side, the length of the side, 2 times X, or 2 times 12.5 centimeters, or 25 centimeters. Now we need perimeter for our formula, so now that we found the side, we'll go ahead and find the perimeter. The perimeter equals the number of sides. How many were there? 6. Times how long each one is, and they're all 25 centimeters, we just found out. And I messed that up, so I'm going to have to fix it. Dang it. I hate when that happens. So, I didn't put 6 there, I put a 5. So this should be 6 times 25, which is 150 centimeters. I'm glad I caught it now. I can go fix the rest of the problem before I record it anymore. Alright, so 150 centimeters for the perimeter. Okay, after the correction, now we're going to set up a trig equation to solve for the apothem. So if we go back and look at our picture, here's the apothem. We're going to be using the adjacent side and the hypotenuse. That's cosine. So we're going to have cosine of the 30 degrees equals the adjacent A over the hypotenuse 25. So again, the cosine of 30 degrees equals the adjacent side A over the hypotenuse 25. We'll put it over 1 and cross multiply. So we got the 1 times A, which is A. The other cross product, we got 25 times the cosine of 30 degrees. Solve for A already. We're going to plug that into our calculator and round it to the nearest tenth. We get 23.8 centimeters. Now we have the apothem. We've got the perimeter. We're ready to solve for the area. Our formula, area equals apothem times perimeter divided by 2. So the apothem 23.8 times the correct perimeter, 150 centimeters, was 1,785 square centimeters. All right. Now after this you'll be doing the practice problems, so good luck, work hard please, and have a good day.